Welcome to the webinar, the Lux Decarbonization Radar, Mapping a Path to Net Zero in Hard-to-Abate Industries. My name is Zhenshen Yu, Senior Director of Research at Lux, and I will be moderating today's session. Presenting today is my colleague Ian Reinhardt, Associate Research Director here at Lux Research. Throughout the webinar, you can type any questions you have in the questions box on your screen. Time permitting, we will answer all the questions that we can. If your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com and we will respond. Throughout the webinar, if you're experiencing technical difficulties, simply refresh your browser and check if your connection is strong. Now, let's jump into the presentation.
Thanks, Yangcheng. It's a pleasure to have this opportunity to share our decarbonization radar framework. But first, I'd like to give an example to make this topic a little bit more tangible. In primary aluminum production, the carbon in anodes is consumed and generates CO2 as process emissions. Inert anodes are an innovative technology that would totally eliminate these process emissions and create a path to net zero for aluminum. The market leaders Rio Tinto and Alcoa have formed a joint venture called Elysis that is bringing this technology to a more mature stage. And the company had announced that commercial production of these inert anodes would begin in 2024. And this is good timing because Rio Tinto is spending over $1 billion to upgrade and expand one of its plants in Quebec, Canada. They'll receive a healthy subsidy from the regional government, more than 150 Canadian dollars, to make a more decarbonized process that will be about 1/7 the carbon footprint of the industry average for primary aluminum production as they upgrade their older smelters to a new technology. Except Rio Tinto isn't going to use this new zero carbon production technology. They'll use an advanced smelting pot called the AP60, which does have low emissions, but not zero. I've selected this example for a reason. Retooling for decarbonization is hard. Even when the technology is maturing and there is government support and demand for low carbon materials, even when the conditions are right, companies are not taking the leap to net zero. This transition is risky, it's expensive, and the timeline is long. But there's a payoff too, and I'll have more to say about that later. So in the presentation today, we'll first discuss this challenge of retooling assets, new processes, new methods for decarbonization. Then I'll explain the Lux Decarbonization Radar framework that we've created to help make sense of this challenge, walk through some of the strategies and timing, and then explain the implications, the so what, and the key takeaways for those of you in innovation roles trying to achieve a more sustainable outcome for your company. And I should emphasize that the focus of today's talk is really on core industry, the so-called hard-to-abate sectors, particularly the highest emissions ones of cement, steel, and chemicals, where we focus the bulk of our research. Now, we also, of course, at Lux cover a lot of the new technologies, the emerging equipment, things that will be necessary for the broader sustainability transition, things like advanced membranes, hydrogen storage, electrolyzers, and we will be continually putting out research on that as well. But again, the focus for today is on the core heavy emitting sectors of industry. So let's take a step back and look at these challenges. As I said, the region that's really moving the fastest and going farther ahead on decarbonization is Europe. And yet there are real issues there. Jobs, a lot of these processes will result in net layoffs or at least changes in the workforce. We'll get to that later. There's also some issues with environmental pollution. Processes that may be more sustainable from an emissions perspective still have to think about permitting. Then there's also falling demand. Will the macroeconomic environment allow for the investments that are required or support a green premium for these products? And higher input costs. Of course, rising natural gas prices that spiked in Europe created a wave of challenges that have rippled through the heavy industries. So before we consider the specific technologies for decarbonization, we must also consider the broader economic factors. So what are these key elements? First, there's the question of existing assets. Do you have blast furnaces for steel or integrated chemical complexes that need to be retrofit? Or do you have an opportunity to do greenfield construction and potentially leapfrog to a new technology? Can manufacturers avoid stranding assets? Next, electrification of industry requires massive low carbon power generation. So at a global level, more than 60% of power generation is from fossil fuels. But of course, there's a high degree of variation between countries and within countries. So can you find the right site that has low cost, low carbon power? Solutions that rely on hydrogen or CO2 capture will be much more efficient when they're connected to robust infrastructure that can match supply and demand at scale, whether that's taking CO2 emissions to offshore geological sequestration or connecting green hydrogen suppliers to a network of industrial users. Where will the public sector and private sector create this new infrastructure? Then the workforce, as I mentioned, there'll be more of an emphasis on high skill laborers. The ratio between capital and labor will continue to favor investments in equipment and probably will be, as I said, resulting in a reduced workforce overall. And then demand. Will mainstream customers pay a green premium? Now, we can see that B2C products are finding some traction, but for B2B, there's very limited appetite to increase even €1 or $1, 1 yen more for low carbon products. Now, a big factor here that could level the playing field in terms of demand, of course, is policy. And policy is really the big framework that's going to set the incentives for companies to make these difficult decisions to invest in the retooling that they need to bring down the carbon footprint of products like steel and cement. So we expect to see a divergence between countries and regions where policy is making these tough choices, imposing an effective carbon price, whether it's through an emissions trading scheme or carbon tax, and countries where there isn't that type of strong impulse. And in the US, for example, it's a little bit more of a push factor. So there is some policy driving it, but regions where there's more of a penalty for CO2 emissions should be taking the lead, and companies forcing companies to make these difficult choices. On the other hand, policy can also be a supporting factor when it comes to procurement, because governments are such large purchasers of especially steel and concrete in the built environment, but even chemical products as well, that any support for these low carbon materials can help to create that bridge to bring a sustainable product to the level of mainstream adoption. And in the case of biofuels, you can say that overall has been a success in helping to establish a market for biofuels. And there in Northern Europe, there are laws, legislation that will force builders to use lower carbon materials in new construction. And in the United States, the state of New York, the state of California have also passed regulations to increase the use of low carbon building materials going forward. So policy can support this demand. Now, what's at stake here for this decarbonization challenge? Because you could say, well, let's let the private sector sort it out. We'll build low carbon where it makes sense, and then continue polluting where it makes sense, and produce a product at the best quality, the lowest cost. Well, what's at stake is that this may drive heavy industry out from the regions where it's traditionally been a strength. I'm presenting to you from California, and the economy here is very strong. We have a lot of high-skilled workers. We have tourism. We have strong agriculture. But in terms of the industrial base, is it going to be a pillar of the economy that creates all those positive externalities, positive ripple effects for development of products downstream and continuing to be a hub for growth? Countries in Europe are very concerned about this hollowing out effect, and that's why they've passed the carbon border adjustment mechanism. The trend across the world in all regions is to be supporting manufacturing, supporting heavy industry, as a key foundation for economic security. And so really the geopolitical trend here is to promote heavy industry and find ways to keep it within borders, to onshore that activity rather than allow the industry to leave and hollow out the economy. So that's the downside, but there's upside too here. Companies that make the right decarbonization investments at the right time will have competitive advantage. If you get retooling right, your company should be a leader for the next 25 years. That's the opportunity that's at stake. But how do you do that? How do you get it right? You need a framework. And that's why we developed the Decarbonization Radar. So here's the chart. You can see there's a lot going on, but once I break it down, you'll find that it's quite intuitive as a visualization. And it's a little bit busy, a little bit of overlap here because we've taken the three reports that we did, one each for cement, steel, and chemicals, and overlaid them on a single chart. So it's got the technology options. Each dot here represents the deployment of a single technology. In isolation, what would be the emissions reduction potential? So that's the color, green being the most emissions reduction, yellow in the middle, red the least. And then the position of each dot on the chart reflects its maturity. So much like a radar, things that are out towards the horizon, that's the rim of the chart here. That's at the lab stage. And as the technology matures, it moves towards the center of the chart, going to pilot, to demonstration scale, and then full commercial scale towards the center. You'll also notice that the chart is divided into three sections. These represent three different overarching strategies for decarbonization. First, there's a makeshift strategy. This is one where you're not really changing the process itself or the product, but you're just changing the inputs. And that's often switching from fossil fuel to a different energy source, or potentially changing the material feedstock in such a way that it reduces the overall CO2 emissions. Then there are retrofit strategies. That's where you're keeping most of the process intact, often using the same inputs, creating the same outputs, but you've swapped out a key stage or added a module like carbon capture to the production process. And then there are transformational approaches. These are ones where you're moving to an entirely different production platform, in some cases going from a thermochemical process to electrochemical process, or even bio-based production in other cases. So let me break it down a little bit further and give you some more specific examples about these technologies that we've analyzed. So in the makeshift section, no doubt you'll notice a lot more red than green. These approaches tend to be lower impact, having lower emissions reduction potential, making small changes at the margin. On the other hand, they also tend to be lower cost, less CapEx intensive, and quicker payback periods. There's often an element of circularity using bio-based materials or industrial wastes as a way to potentially lower costs as well, and then reduce the carbon footprint of the material that you're producing. As an example, I would point out biocoal. That's produced by the torrefaction of biomass between 200 and 300 Celsius. And biocoal can substitute for pulverized coal injected into the blast furnace. Although, because the energy density is lower, the maximum substitution rate is probably around 20%. Now, with public funding support from the EU, ArcelorMittal has constructed a 35 million euro plant in Belgium that's producing more than 37,000 tons per year of biocoal from wood waste. But the greater long-term challenge is sourcing wood waste. In this case, their supplier has admitted demand definitely exceeds supply, so it may not be such a scalable solution. When we look at the retrofit solutions, you see it's more of a mix. There are some here with quite high potential, some early stage, some that are really scaling up. The sharp-eyed among you will no doubt have also noticed that the CO2 capture is on here in 3 different places. As I said, 3 different reports overlaid here, and it's at slightly different stages, different efficacy for steel, cement, and chemicals. And other ones to highlight, electrifying certain processes like an e-kiln in the case of cement, or an e-cracker for chemicals production. The specific example I'd like to highlight is gasification. And that's the conversion of lignocellulosic feedstock or municipal solid waste into syngas, which can be converted to methanol. Using a gasifier to produce methanol eliminates the need for a natural gas reformer, thus we call it a retrofit. Now, gasification technology is at scale, but only for power generation. The solution remains unproven for chemicals production, which requires higher quality syngas. The Dutch company Gidara Energy will launch 2 gasification projects in the Netherlands in 2025, building 90,000 ton per year biomethanol plants in Amsterdam and Rotterdam. And that brings us to the transformational section here on the right. And again, no surprise, these tend to be earlier stage. Many of these even at the lab or just graduating to pilot, still relatively low technology readiness level, TRL. And the big difference here, though, is they're almost all green. So here, these are the options that can really get you to net zero, that are ways of almost totally decarbonizing production. Although, of course, it would represent heavy investment and in some cases, shifting the value chain to very different inputs in the case of, for example, bio-based concrete. I'll highlight the startup Biomason, which was founded in the US about 10 years ago, and they are producing a bio-based concrete. It's a bacterial production method, similar in some ways to brewing beer. They're like a fermentation process where they're growing these bacteria that then they pour into molds with aggregate and water. And the enzymes in the bacteria produce a calcium carbonate, similar to a coral formation, and that creates the strong bonds of a bio-based concrete. So the block dries, dewaters, the microbes die, and then you're left with a product that has similar performance properties, similar compressive strength to a traditional concrete, but at a very small fraction of the CO2 emissions because the microbes are taking CO2 from the atmosphere to produce the calcium carbonate. And this company is now reaching the demonstration stage with a product with a partner in Denmark, and the blocks are on the market already through their reseller in the Netherlands. So I've given you some examples of what decarbonization looks like. We've talked about a few technologies and these different strategies, but in many ways, what can be an easier question than when? And for the next part, I'd like to ask, when do you apply these strategies to retool your manufacturing facilities? And the answer to that is really based on the service life of your assets. What is the remaining lifespan? What's the type of capacity that you want to be constructing in the future? So for those factories, those facilities that are nearing the end of their service life, 10 years or less remaining, that's where makeshift approaches really make the most sense. As I mentioned, these tend to be quicker payback, less CapEx intensive, and in some cases even saving money compared to incumbent materials. And that this can also be a way to get a little bit of climate impact in the remaining years of a factory. But you're really not going to get the big changes that we would need to see to get to a net zero solution. Where that transformation starts to make an impact will be in the next decade, and probably in the later part of the next decade for many technologies. As I noted, things like electrolytic production of iron for green steel and bio-based concrete. These are really early stage, but with another 10 years of development, 10 years of scaling, tackling the challenges, and working through the issues of getting to commercial stage, it should be good timing to replace the high emitting assets in the late 2030s or around 2040 with a transformational approach. And that's where you can get major change, 90% plus reduction of CO2 emissions. And then you won't be worried about stranding assets, because do you really want to be building, say, a blast furnace in 2040? Well, if that's going to be a 20 or 30, 40 year live asset, what does the emissions profile look like in 2050 and beyond? it's going to be quite expensive to deal with. So that's why we think the timing will be right for this transition in the late 2030s. Then for assets that are still young, maybe a plant that was built in the early 2020s that's got lots of service life left, that's when a retrofit solution can have the most impact, where you're, for example, adding a CCUS or perhaps switching to hydrogen as your fuel source, going to direct produce iron for steelmaking. And even though there's plenty of time to take this action, the earlier you do it, the more climate impact there will be in a positive way. So there is still some urgency here. And taking advantage of the right policy context will be valuable, as the incentives, in the case of tax credits or emissions trading schemes, will often determine what's the most economical approach there. But for this last section, I'd like to get into more day-to-day issues, thinking less at the high level, the super strategic level, but what's going to be something that you can put into practice as an innovation group, as an R&D group, or a sustainability office. I've got 3 pieces of advice here. The first is to get in early for these transformational startups. And in many cases, that would be an investment, although there can be other ways to partner, perhaps providing some contributions in kind and developing a pilot system with the engineers and developers from these transformational startups. Because what you'll find is that the knowledge is really valuable in setting your strategy for the future and understanding where the pain points are, what are the obstacles, or what could be a hurdle that your company can solve easily by plugging together with a startup and getting one of these 2 + 2 = 5 type outcomes. And then if you are making investments in a portfolio of transformational technologies, startups trying to disrupt the system, then if there's time to acquire them and you want to bring this technology in-house for competitive advantage, you're going to make that acquisition price much more reasonable with the investment. The next point is about the workforce. As I mentioned, you're going to need new skills. You're going to need a well-educated workforce. And here, trying to bring in new expertise will be really valuable, again, to help set the strategy. Because if you're thinking about, for example, a switch to bio-based production, you're going to want some biology experts. Maybe you don't have them there. So bringing those folks with factory floor experience, as well as strategic leadership, will be really valuable. And often it's the experts in an industry who know the tough questions to ask, and they may be skeptical about new approaches. And that type of caution can also be helpful before jumping with 2 feet into an exciting but unproven process. And then third, building an ecosystem for innovation that includes collaborations up and down the value chain, as well as potentially with competitors, can be really important to develop the infrastructure that will be necessary for some of these changes. Particularly, I'm thinking about hydrogen and carbon economies. They're spreading supply and demand across many nodes will be very important to get a robust and resilient trade going. And then the innovations that support that, it's much easier to create that through a sort of innovation cluster where the industry is able to share needs with academia, express their problems to startups that are working in a trusted relationship, and they can be trying to the startups can target their own R&D at solving industry pain points. So working together in this type of collaborative mode, although many companies are not used to it, has a great payoff. Now, I said that retooling and decarbonizing will lead to durable advantages for your company. So as we wrap up, let me review those. First, energy supply resilience. In most cases, adopting these decarbonization technologies will lead to a more local and more stable supply of energy. And especially when it comes to electrification, that will be of necessity sourced from your country, the region where your plants are operating. And so going to a lower carbon footprint will have the advantage of being much more resilient to external supply shocks, price spikes in fossil fuels. Second, the advantages that your products have by becoming low carbon will ripple through the supply chain with positive effects for all the downstream buyers. So if you're making a zero carbon iron, that creates the possibility of zero or low carbon steel. And then the buyers of that steel, then they have a very low carbon product to sell. And perhaps they're making components, and those components go into electronics. And the electronics now can advertise an extremely low carbon footprint, often most of it coming from the steel that's in those components and of the equipment. So the ability to not just sell something that helps meet your customers' needs, but then creates a final product for the consumer that has that sustainability appeal will be valuable through the economy. And last, it's not only the products, but the processes themselves that can be part of your business plan. Because as the global sustainability transition happens in waves, regions that are ahead will be the first to develop the decarbonized processes. And then that system itself could become a technology export, whether through licensing or some type of service arrangement. Your company may be able to leverage this advanced process that you've developed to then sell it to other companies who are trying to follow in your footsteps as a decarbonization leader. Wrapping up, I'd like to leave you with these 3 key takeaways. First, policy is really critical, and it creates the market incentives that will lead to investment in decarbonization. And that can be both on the sort of pull side for procurement incentives that are encouraging governments to purchase these low carbon materials. It can also be through push side, forcing companies to deal with carbon taxes and emissions trading schemes to pay for their emissions. Second, even though this transformational change that I talked about will be next decade or even the later part of next decade, that doesn't mean that there's no urgency. And in fact, the preparations that you make today will be really critical to setting that strategy. As I mentioned, working closely with startups, getting involved with pilot projects will give you the knowledge that you need to make the right choice when the time comes in 8, 10, 12 years. And lastly, cooperation between companies that are competitors overall can be extremely valuable for setting up the infrastructure, because these projects are really expensive. And the ability to match supply and demand for hydrogen, or in the case of carbon, finding ways to utilize CO2 through connected pipelines creates a lot of positive externalities. And that includes getting public support. There have been examples of competitors working together on projects so that they can get quite a bit of subsidies from the central or regional governments to support the expensive capital investments in this infrastructure. So compete on the product, cooperate on the infrastructure. And that wraps up my presentation today. Thank you very much for your attention.
Thanks, Ian. We'll now take a few of the questions that showed up in the question box. As I mentioned earlier, you can type into your questions in the bottom of your screen, any questions you may have. Of course, if we do not get to your question on this call specifically, someone from Lux will be in touch after the webinar. So the first one we have here, and not a surprising one, but question is, how does the hydrogen economy play a role in sort of the retooling of these industries that you talked about today? What's the potential in your opinion?
Mm-hmm. Yeah, well, I think the impact is going to be felt a lot much more in steel and chemicals of the 3 sectors that we focused on. It's a little bit less relevant for cement, although some companies are using it as a low carbon feedstock. But it can be a key part, especially for steel, of creating a potentially zero carbon iron through hydrogen direct reduced iron production. the main challenge there is really cost. I've been interviewing quite a bit of steelmakers recently, and they see the technology as mature, but can you produce hydrogen at a low enough cost, down below $3 per kilogram? That seems to be the real hurdle right now. And similarly for chemicals, there are some good options to use hydrogen as a feedstock, both in retrofits and kind of makeshift approaches. But it's a little bit more case by case for the chemicals industry, where they can get that green hydrogen supply.
Excellent. And I think this next question is fitting, as you mentioned, the steel and chemical industry, as well as the cement industry. Of course, everyone wants to know, can the radar be applied to other industrial sectors?
Sure. Yeah, I did kind of a curveball there by bringing in aluminum first, and then not talking about it much. So certainly, yeah, we did want to start our research off with the heavy emitters, but the framework itself is very flexible, and it would just be a matter of establishing the sort of life cycle analysis type work that we did to understand the emissions reduction, plotting those, and then building up the knowledge through different case studies. So yeah, if anyone's interested to talk with us about what that might look like, for example, aluminum, yeah, we could help to build that out.
Excellent. Looks like we have time for one more, and I actually really like this one because I think it's one of my favorite takeaways from the end of your webinar. Can you elaborate a little bit more about compete on product, collaborate on infrastructure? Any examples you can share highlighting this strategy?
Yeah, sure. I think a good example would be from Japan. The government agency JOGMEC has put out a tender and granted the first round of applications to build these big CCS hubs. And there you have sort of the titans of industry there, including some of the trading firms, the big steel and cement makers, and chemicals makers, including some where there's competitive elements where their business lines are overlapping. But they've collaborated on these big CCS hubs because it doesn't really make sense for a single company to be building it out on their own. So they'll get some subsidies to start it off, to help the development and design and front-end engineering here. And then the next round will be decided, where the government commits even more money to create that infrastructure. So it's a great example of a kind of multi-layered coalition on the private side, as well as the right amount of support and incentives from the government.
All right. Well, thank you, Ian. Thank you all the attendees. That concludes our webinar for today. As always, the slide presentation and recording from this webinar will be sent to all of you via email later today. After leaving the webinar, you will be prompted to complete a survey on today's presentation. We, of course, would appreciate any feedback you may have to help inform and improve our future webinars. At this time, thank you very much, and please take a moment and check out our upcoming webinars shown on the screen right now. Thanks for joining us, and have a great day.
Thank you very much.